Hey everyone, my topic for today is Platform Engineering 101 with Backstage, where I'll be talking about what is platform engineering, what are its principles, what are the goals that platform engineering aims to solve, and how does Backstage fits in all of this. And along with this, short demo on the platform. So I already introduced a bit about myself, and here's the short agenda for today, which I discussed. Now let's get started on what is platform engineering, why was this term even present, and how this helps organizations. So my first question is is this just another like a repackaging of DevOps engineering? We know that DevOps engineers have been they are like solving more or less the same problems, that is about writing your CI/CD pipelines, fixing your deployments, fixing any issues that you might have in production. So is platform engineering just another repackaging of DevOps? Actually, that is not the case. Platform engineering is about designing and building tool chains and workflows that enable the self-service capabilities, which means that this is kind of a bookish definition. So if I might simplify it for you, then it would be just that platform engineering helps developers to build their applications and also have the best practices from day one without having to learn about the tool chain that might be there. So one of the example could be like, I don't want to, let's say I'm a new developer and I just want to get started with developing a particular microservice for my organization. And I just don't want to, I don't know much about like what's the CI/CD tool of choice that's being used. What is the uh, what's the packaging mechanism, and what artifacts, where the artifacts are being published. I don't want to know about that. I just want to build my microservice and want to deploy it to the and I want to deliver a feature uh, for my product. So platform engineering helps you enable uh, that you what this platform engineering does is you build your tools, like you build your service. We will help you build what's the t- t- uh, later phases of software development that might be there. So coming to back to my example, that would be my so the platform engineering team would help build the CI, write the CI/CD pipelines, not just write, but rather just define that this is the CI/CD pipeline that you need to use. These are some of the testing tools that you need to use. Uh, this is how your Kubernetes manifest should look like, so on and so forth. So when it comes to platform engineering, we have a few principles that we need to stick to. First, you need to define a clear mission and role. So one of the examples could be that we want to build reliable workflows that allow engineers to independently and interact with our setup and self-serve the infrastructure that they need to run their apps and services. Like one of the examples, like if I were to simplify this, it's just about like you want to develop your you want to give self-service capabilities such that devs can create their own testing development infrastructure. They can test out their feature and deliver the feature to the production. So that's one of the example mission that I gave. This could be something similar which you can define for your platform engineering journey. So it should be defined from the get-go. It is also it is also extremely important that you set up a clear role for your platform team, and it shouldn't be all of just another thing like that. You just go and create your dev environments on demand, but it should be just it should be treated as a dedicated product to serve your developers, which are your internal customers. Now, second principle is that you need to treat your platform as a product, meaning that you need to have a product mindset when you are setting out with your platform engineering journey. That is, whatever your platform is, your product is. In this case, it would be your internal developer platform. That would be your product. you treat it as your treat it with a product mindset. That is, you go out and you do user interviews. You seek out what features they would like to see. You iterate upon that. You have an agile life cycle, and you develop a roadmap on what features you would like to develop in your product. So on and so forth. So that is that's the like the complete life cycle that you should follow for your internal developer platform. Next is, you should focus on your common problems that is there. So you shouldn't set out to solve unique cases from the get go. You should first see that what are the common problems that are out there. Say someone is having a difficulty writing the CI/CD pipelines, or someone is having difficulty to create dev environments for testing out their feature. So these could be like some of the common problems that could be there. So you should be focusing on these kind of common problems and solve them first, uh, and make it as part of your first set of features for your IDP. Next is, your glue is valuable, which is essentially like, whenever if I talk about if we talk about like platform engineering from a CEO's mindset, for example, then they would see it as like a platform engineering. They would see it as a cost. That is, it would be a cost to the organization. It wouldn't be something like like platform engineering teams don't go out and solve your problems in the production. They are just there to glue together the systems, and that's it. So a CEO or like someone from finance would think like, why should we fund this platform engineering team in the first place? So the thing is, you need to that is like that first of all, that perspective, it's a dangerous one. And second, that this platform engineering, that serves as your valuable glue, that where it the job of platform engineers is to like glue together all the important tool chains, all the tool chains and components that you have within your organization. You glue them together and and develop a solution in such manner that this such that the developers, they have a frictionless development, and they can deliver the features faster. So those are like, that could be like one of your value propositions that you can share with your manager when you are proposing to set up a platform engineering team. Next is, you don't reinvent the wheel. You don't like you don't create new solutions to problems which might be solved by someone else. You use whatever that's available uh, out in the market, or within the organization. Just try to use them as it is, and glue them together and use within your internal developer platform. So yeah, some commercial solutions, they are more likely they are going to optimize for the generic needs. So whenever there is example like any specific problem that you are trying to solve, then in that case, and which is very specific to your organization, then in that case it would make sense to invest and develop a solution. But more or less, the focus should be on solving the problems which are more common, and it could be like solved quickly. Now, if I were to talk about how this fits in a modern engineering organization, so generally there are four fundamental topologies that are there with any engineering org, which is four types of teams. First is your stream aligned team, enabling team, complicated subsystems team, and platform team. So stream aligned team is your developers. That is, they are assigned to a flow of work. They work on the core business logic, and they solve that particular thing. So if I were to relate an example to this, let's say you have your e-commerce platform, and within there you have like multiple things. Say one is for your machine learning systems, one is for your search schemes, one is for your how the product is displayed. So those are like some of the examples that I gave. That could be like specific work streams for your product, that is your e-commerce domain. Next is on the enabling team. Enabling team, they are like a simple example is your quality engineering or your quality assurance team, your QA team. They help to overcome any obstacles that are there, and they help to detect any missing capabilities. So this could be like I said, that this is a example of a QA team. They help to detect any problems, and they help to you to overcome any obstacles that might be there. Next is on the complicated subsystems team. So whenever you have any significant technical expertise that is needed. So coming back to our e-commerce system. So when if I want to have uh, say a very let's say I want to develop a completely new machine learning algorithm from scratch, or say I want to develop a new model from scratch, then I would like to form a significant specialist team which would be tackling this complicated problem, and they would be helping to break to solve this particular problem, and where it would help to deliver on that solve that particular problem that's there, which is complicated in nature. Next is last and but not the least, our platform team, which is the job of a platform team is to provide a compelling IDP, internal developer platform, to accelerate delivery for the stream aligned teams. So that is how like the modern engineering org looks like. And platform team, as you have seen, it is involved in the entire life cycle of the streamline team, and they help with the whenever with any issues that might be there when it comes to delivering the feature to the production. So yeah, next is, let's talk about what is an internal developer platform. I've been mentioning this for some time, that what is it and what is it about. So platform, internal developer platform, it's the product which is built by the platform engineering team to build golden paths and enable developer self-service. Now, what is a golden path? So, for example, like any golden path would be like one example would be your CI/CD pipeline. That is, you build your image, you update the image and all the configurations, and just you are done with it. But let's say you want to have more other features, like for example, I want to have add environment variables, I want to have my services and dependencies, I want to have my RBAC systems, all the refactoring that's there, spinning up any new environment. So all these kind of like golden, these kind of workflows that you would like to have, these are called golden paths, and that is where IDP would help you to achieve this. Internal developer platform consists of many different tools and technologies. They are glued together to have lower cognitive load. So one of the examples is, yeah, let's say you are using Terraform for your infrastructure deployment. You use GitHub Actions for your CI/CD. You use Kubernetes along with Helm for your for deploying and running your applications. And you have multiple, like you use another like some ingress technology for deploying your API gateways. So all these tools and technologies that I've just mentioned, so all of these are glued together and they are made available to you as part of the internal developer platform. And as I mentioned, platform engineering treats this IDP as a product, and it is built on user research. It is continuously maintained and it's improved continuously. So what are the core components of an IDP? So I've listed five core components. This could vary with any other organization. They could have uh, even more components compared to this. So these are the core components. First is your application configuration management. This enables you to have your application configuration as code in a dynamic, standardized, and scalable manner. Next is your infrastructure or orchestration. That is all your existing orchestration tools that I've just mentioned. For example, Terraform. This could integrate your Terraform could integrate with your IDP, and it could be orchestrated by the internet developer platform to enable continuous delivery. Next is environment management. So with IDPs, developers can self-serve fully provisioned environments on demand basis on the definitions that are basis on the definitions or standards which are set by the platform engineering team. Next is on deployment management. So whenever deployment automation that you would like to have, it enables teams to move to continuous delivery and also provides a clear record of each deployment agreement. So as you have noted, you might have noted that the fourth point, it is very similar to what CI/CD, let's say GitHub Actions does, right? So GitHub Actions kind of falls within the IDP, but the IDP kind of helps you to view all these records within a single pane of glass. You don't need to jump around in GitHub's UI to check your deployment records. Next is role-based access control. So whenever you want to, whenever I have, let's say, multiple teams, let's say one team for my search, one team for my product history, one team for my machine learning related technology. So all these could be defined as multiple teams, and you can control like what team is can see which components. You can control them via the role-based access control RBAC, which is available within the IDP. It can also help you to limit the production access to a small number of people while allowing every engineer to create new deployment environments as needed. Now, this is an example of an internet developer platform and how platform engineering ties to here. So, if you might see, if I can, put the, I hope you can see my mouse cursor here. So, first is about.
Yes, we can. We can. Okay.
Thanks, Mithul. So first is about the product and application teams. They work with the platform interface. That is, it talks about like documentation and search, what templates I want to use for projects and for my environments, what is the UI I want to use, and what is the API and CLI I would like to have. So this product team would be integrated here. They would be responsible for this platform interface and for the capabilities of the platform. So as you can see that it does have many lot of capabilities actually, that is to provision all the infrastructure that is for your databases, your compute network, storage, all your identity access management, your secret management, your artifact scanning, artifact storage, and observability and everything. So these are the kind of capabilities that is there within an internet developer platform, and it is the responsibility of the product, the platform team to maintain this, and it would be the application teams and developers who would be consuming uh, these these capabilities within the IDP. But why do I need a platform engineering? If I already have a I already have a DevOps engineer at my organization. He's already seeing all my CI/CD pipelines and everything, and also works for all of the deployment related things. So why do I need this additional team? So like one there is a one if I were to define like take this with a single word, the answer is speed. That is, we work only on you essentially develop this platform engineering team along with your internet developer platform to increase the productivity. You streamline all the developer environments. You standardize everything. That is how your code convention should look like, how you should maintain your documentation, how you should write your test, how you should write your particular health chart for your microservice, so on and so forth. So all these things you would like to have a set standard to be followed across the organization. So their platform engineering can help you with that goal. Next is on the improvement of your DevOps metrics. So if I were to talk about DevOps metrics, which is like mean time to recovery, that goes down. That is, if you have all your platform, all your services, all your microservices that are there, if all of it is defined in a single pane of glass, and if there is any incident that is happening, any production incident that is happening, and I would like to know that which that whatever component that has failed, who is the owner and who is responsible for that, then you can direct your questions to that team, and they can help to recover on that particular service faster. So there your mean time to recovery it decreases, and that helps you to recover faster from your incident. Next is change failure rate. That is whenever you have all these changes, if you're deploying any changes, and if those changes are going to production, and if it is failing due to some or the other reason, then that change failure rate also goes down, and it can help it can help in the product to have lesser number of failures for your platform, for your application. Next is your deployment frequency increases. So any developer, they would be enabled to deploy more to your to the production environment, and that improves your your feature delivery to, and your you have a faster time to go to the market. Then any lead time, that is if I were to build any new feature, if I'm set out to build out any new feature which is there in my product, so that I can have a faster development frequency for that, and that decreases my lead time for that particular feature. Now let's talk a bit about Backstage. So Backstage is like one of the tools that can help you to build your internal developer platform. There are many tools that are out there, which both commercial and open source, which can help you to have a platform engineering, and to help you with your platform engineering journey. So, what is Backstage? Many people have this misconception that Backstage is it's an internal developer portal. It is not. Backstage is it's a framework which helps you build your internal developer portal. So, as I mentioned, that internal developer portal. So, as the name suggests, internal. So, it is internal to your organization, and each and every organization can have a different way of defining what their practices are, and how they would like to streamline their developer experience. So it could be different. So Backstage can help you to build that customized experience for your org, and it can help you to streamline your developer experience. So, it unifies all your tooling, services, and documentation. It creates a streamlined development environment. It was created by Spotify Engineering. It started out. It's currently a CNCF incubating project since 2022, and it is built with your React, Express, Docker, Postgres, and Yarn. These are the technologies that Backstage is built with. So, what are the benefits of Backstage? So, if I were to talk about benefits, then let's take it with the four sets of users. So, first set of user is your engineering manager, where the EM can maintain the standards and best practices across the organization, and it can help to manage the entire tech ecosystem. Then, for your developers, it makes it fast and simple to build software components in a standardized manner, and it provides a central place to manage all your projects and documentation. For the platform engineers, it enables the extensibility and flexibility. You can integrate new tools and services via it, and you can extend the functionality of your existing tools. And for everyone else, it provides a single consistent experience that it ties all your infrastructure tooling, resources, standards, owners, contributors, everyone is there in the same place. So this is like a simple screen guide that I took from the Backstage website. So you can see that we have all the service definition. This I'll come to it in a bit. You define it in a YAML specification. Then all of these definitions that you define, they are all visible in the Backstage catalog, service catalog. It's all visible here. And then whatever other tools that you might want to integrate, say GitHub Actions, Prometheus, Istio, all these tools, Then you can integrate all of them via the plugins that's available in the Backstage marketplace, as well as you can develop your own plugin. So as I mentioned, that everything in Backstage is a plugin. So we have like few core features that are here. One of them I've just not mentioned, that is Kubernetes. I'll come to it. So first we have the software catalog. So all your microservices, data pipelines, libraries, everything you can have it defined in your in a catalog. Then second is software templates, where you spin up, with which you can like spin up your new projects quickly, as well as standardize all your toolings with the organization's best practices. Tech docs is, as the name suggests, that it's all about like where you maintain your technical documentation, and you can have it as a documentation as a code. And also there is another core feature, which is the uh, Kubernetes plugin, where with which you can have all the visibility of what's the deploy of your deployments, your services, and your components, every in of your Kubernetes cluster in the in Backstage. There is also a growing ecosystem of open source plugins for your further customization and functionality. Like you can customize Backstage uh, however you like, and with the use of open source plugins. And there's a growing community, growing ecosystem of that. Let's talk about software catalog. So it maintains your services inventory. So it's a centralized system for keeping the track of all the ownership and metadata of all the software. That is, it could be your services, it could be your websites, it could be your libraries, so on and so forth. So all this catalog, it's built around the metadata YAML files. This is all stored together with your source code. So which is then like harvested, and it is utilized within Backstage. So here's how a software catalog would look like. That is all your components that's in here. That is, it could be, this is an example from the Backstage demo website, which I'll showcase in a bit. So this list all the components that are in here, and which is part of which system, who is the owner of who is the owner of that component, and what is the life cycle of that particular component. So you can have this list of all the components which are utilized in your application. Then you can have multiple. So here is one component that I've opened, which is like a dice roller component. So as you can see, it has this Kubernetes tab, as well as CI/CD tab, dependencies, and whatnot. So these are like these kind of integration that you can see what Kubernetes cluster it's deployed in, and what's the CI/CD process of it. So you can have all of this integration via the plugins that's mentioned, that's available in the Backstage marketplace. This is one example of the software catalog which is there. So this kind of looks similar to a Kubernetes manifest, which you might, where you can say that, yeah, that's the case, because it does have these things of what's the links that you want to showcase, what's the type of the component, who is the owner, and what are the API dependencies. So you can define this catalog metadata as part of uh, your microservice, and it can help you to make it visible within the Backstage UI. Now let's talk a bit about software templates. It helps to create golden paths for the new service creation. So as mentioned that software templates, it follows this procedure called scaffolding, which helps you to create all the components inside Backstage. It has the ability, by default it has the ability to load a code skeleton. It will template in some variables, and then it would publish that created generated template to a location. Like for example, if you are using GitHub for your source control, then you use then that new repository that is then published to GitHub. So this is one example that's there. So one example could be like if I have a Spring Boot service, and if I would like to, if I go and select it, and it would show me that what's the uh, uh, like it would ask me some more details to fill in, like what's the name of the service, what's the description, what would be the API endpoint it would be like, if you will. And that way I can just define that way. When I choose the when I start the template creation process, it would go on and it would go on. It would run its own Backstage does have its own internal CI process. So it would run that process, and it would build the software template, and it would publish that repository, that newly created template repo, into GitHub. So here's one example of a software template. So here's the, like, as you can see that this is on a scaffolder API version it uses. And you can see that it has this template. It asks for the details, like what parameters it is asking for, like what's the title of this, who is the component, who is the owner, like what's the name of the component, who is the owner of this component. And once these details are filled in, it would start to create the skeleton. It would start to create it would get the skeleton and would render out the template. Now these are the parameters that it accepts, my skeleton accepts. And then once these parameters are validated, it would then publish this to a GitHub repository. And as once this GitHub repo is published, then it would register within the Backstage. It would do the registration also within Backstage as well. So you don't need to, once you create the new component, you don't need to manually register it into Backstage. Coming to tech docs, it is another core feature within Backstage, which is all about like docs, like code solution, which helps to build thing, like which helps to like whatever your markdown files, your technical documentations are. So they live together with your source code, and with small configuration, you get a documentation website for your component within Backstage. So this is one example that it can show this Backstage docs as well, like about what like any documentation that I might have for my component. Time for a quick demo. So here's the Backstage demo that I've just opened. So this is accessible to everybody, and you can also like go on and check in that what is this about. So as you can see, as I mentioned, that it has this list of components that's here. So this is again the example from the Spotify's own product, like some of the components that are mentioned. So one of this could be, let's go to maybe artist lookup. So as you can see, it shows me that what are the relations, what are the dependencies this component is on, who is owning this component, and what system it is part of, and what other dependency it might have. So here I've just clicked on artist DB. So it shows me all the details about like what is it about, like any subcomponents that it might have, so on and so forth. It would show about my CI/CD related things also. So this is again enabled via the plugins that's installed here, and that can help you to define about like what's your CI/CD process, about your Swagger API spec that you might have. So if I might show you any component which is having this, so let's go here. So if I want to show the API, okay, not here. Let's take this API. So I have this as API. Okay. Let's say this API spec which is there. So it can show me
Aditya, can you zoom in a bit? I think, yeah, this screen. Yeah, now it's good. Okay.
Thanks. Sure. So as you can see, apologies if the screen wasn't. So here it shows about what's the GraphQL definition for that I have, and this shows me about what's the component, what's the relations that it is having with, and all the other details. So here I can see that what's the this detail all about. So let's say if I open any open API spec here, and I go to definition. So yeah, this is what I wanted to show. So here you can see that this is a simple like pet store open API spec which is there. So here you get a Swagger UI as well. So if you are having the relevant permissions, then you can do the with the Swagger API call. You can test out the call here itself, and you can see all the details in here itself. That what is it about? So here also you can have a with your Open API spec defined properly. Basis on that, you can define you can have this Swagger UI for yourself, and you can test out your API specification. Yeah, and that's the catalog part. Now, if I were to show the documentation side, so let's say I want to show this Backstage, this documentation, for example. So here I have this Backstage documentation itself, where I can just see that what is it about, like what are the definitions. Like if I want to navigate within this documentation, then it allows me to do this via via the TechDocs plugin. So this helps me to navigate the documentation here itself without having to step out into any other UI. Say maybe like something like Confluence or something else. Yeah, so that is more or less about the demo part. That concludes the demo. And now I open the floor to any Q&As that might be there.
Yeah, sure. So let's hope for the questions. Let's folks, you can ask your questions if you have any, right? Now's the time. So yeah, I think we have a question which is, okay, what inspired you to explore platform engineering and Backstage?
So platform engineering, I would say it started off as a kind of a necessity within my org, where it was where there was a requirement to like explore all the internet developer platform that might be there, and also how to enable like self service and smoothen out the process for the developers faster. So all these kind of questions they like inspired me to explore platform engineering and also leverage Backstage for my requirement. So yeah, hope that answers your question.
Yeah, I got it. Like starting with the like issues, I guess, like how it solves the problems and so on, and then you explode it, and I think then the Backstage. Okay.
Yes.
Another thing is, okay, how does Backstage simplify the management of Kubernetes resources and applications?
So Backstage is all about like it shows you in it's kind of a UI for the developers. If I were to oversimplify it, but so any sort of like Kubernetes applications that you might be there, that might be there in your in your environment. So you can visualize that how it is deployed, what is the status of that service, and you can like essentially own that particular service in that particular environment without having to ever
Okay.
log in into the Kubernetes cluster. And that way you can ask the your site reliability team to maybe like check out the service within this particular environment to see if there are any issues, or maybe like check it out yourself if your organization allows to, maybe has that policy to you build it, you own it kind of policy. That is uh, yeah. So hope that answers your question. So Backstage essentially provides the UI for your component for your particular service, and then it's up to you how do you would like to address any issues that might be there. That is, yeah.
Okay. Another question, that is, how do you see platform engineering evolving in the future, and what role will Backstage play in this evolution?
So, platform engineering is one of the main goals that it helps to satisfy is like simplify the developer onboarding. I think we have a session down the line as well. That so whenever any new developer would like to joins the organization and they would like to learn quickly about what's the component and what are the applications that he's working on, and he would like to learn more about it. So he can just self-explore the all the details and all the components within Backstage, and they once they are good with all the things that they need, they can start developing on that service quickly. So that's one requirement which is fulfilled by platform engineering. But later I see that it helps to even self simplify, like enable more developer self service for the organization. That is, it helps to developers just let them do their job, and we don't interfere in their things, like working with the, like for example, any security patches that they might need to do, or anything like how to maybe like improve the how the application is deployed, so on and so forth. So there could be like many such things that the developer needs to do, and all of this we can just remove them off that all these things off their plate, and they can just focus on the development and delivery of the feature. So yeah, I see platform engineering evolving into these two directions, and it can help to fulfill these two goals.
Okay. Another question from Abu side. What are the prerequisites of learning platform engineering? Any suggestions for like undergrad first year student? So yeah.
Yeah. So if I were to take mention about like the first year students, I would say that platform engineering is, it's too niche of a platform, like too niche of a discipline to get into right now. Platform engineering is all about like you get a few years or years of experience uh, in maybe like things like software development. And software development is, I would say, is the ideal path to get into platform engineering, because when you are developing software, then only you will realize that there are many such or even if you are a data scientist also, you would be involved in some part of your development career, that you are deploying any service to the production environment, or you are monitoring any service, or you are part of any incident response process where you learn more about the service and its dependencies. So once you are, you get a few experience there, then you would have a chance to to learn more about platform engineering, and then you have a good opportunity to learn more about it. So hands-on experience is necessary.
Yeah.
Yeah.
Obviously. Okay, so I think with that we will wrap. This is the last question we'll take. Like, does system administrator can start his career in platform engineer who has primary knowledge in DevOps?
Yes, I would say that system administrator already has, they have already seen the things on the operation side of things, that um, how the system is deployed, what are the configurations of the system, what requirements does the application have to run successfully. So all these, they already have this knowledge from the operation sides. Now, to get into the platform engineering, again, it requires a bit of, as you have seen that the Backstage, it's not like a simple, like a one person effort. It requires a bit of platform, like it requires a small platform engineering team to build it and maintain it, and to build a platform to build this kind of like internet developer platform. You need to have some experience with software development, say maybe like working with React, working with Node.js, and Docker, and so all the software development side of things also like comes into play. So I would suggest that if you are coming from a sysadmin background, or even a operations background, then I would suggest to have a bit of knowledge on the how to uh, on building JavaScript related applications, because when you are building your Kubernetes, your Backstage plugin, that is the place that you will be working, that you will be involved most, and that's when you will need that knowledge of software engineering there to become a platform engineer.
Yeah, I think we have actually more questions, but I don't think we should take more questions because yeah, we have some questions, some sessions coming up, right? So yeah, thank you so much, Aditya, for an awesome time, and yeah, so yeah, thank you so much, and with that, I think we can end our session, right?
Thank you so much. And Yeah, feel free to join me on like I have my LinkedIn also as well.
Yeah, feel
If
free
I
to
might,
just share here. I guess I can share that. Okay, wait.
I'm just
Okay.
switching to that slide itself. So
Okay. Yeah, great.
yeah, it's in here. So you can connect me here on LinkedIn, and I
Okay.
am feel free to ask away any questions that you might have for platform engineering or DevOps.
Okay.
I'm happy to answer.
Yeah. Yes, awesome. So yeah, let me. Okay, thank you so much, Aditya. Then, and I hope to see you soon. Okay,
Thank you so much, Mithun.
bye.
Bye.